All right, here we go. So we are now covering lessons on linear inequality. We actually have 3 lessons that are basically the same lesson because all of the material is the same. Some of the vocabulary is a little different, so I'll just go over all of it. Lesson 1.6, lesson 2.R.6, and lesson 2.R.7. You can see above my head. There's my list. So here we go. I'm just going to go for it. Let's just start learning how to solve these linear equations. Let's start off with a very, very easy linear equation. X plus 5 equals 7. I mean, we're starting at the bottom here, and that's okay because you need to understand what the word linear means. Linear means it creates a line, but it also means that our variable is secretly raised to the first power. You've seen something along the lines of x squared before, right? Or even x cubed before, right? Well, x to the first power, we don't actually write the 1. We write it without the 1 like this. Anytime your variable is raised to the first power, you're talking about a linear equation. So let's go ahead and solve this thing. In order to solve a linear equation, we have to get the variable alone. So here's my x, and right now it has positive 5 attached to it. We need to move the positive 5, get rid of it. Think of a scale, right? If I had a scale if I had a scale and I got a marker in each hand right now, right? I am an old school scale. If I were to get rid of one of the markers, you didn't catch it. If I was to get rid of one of the markers, then wouldn't my hand do this, right? Because the heavier hand would keep the scale balanced. Ready? You ready? Wake up. To keep the scale balanced, I got to balance it out, right? Okay. See, look at you. He caught that one, by the way. Look, y'all, we trying to have fun with this because this is miserable, just being honest. We're trying to have fun with it. So in order to remove this 5, I've got to make it 0. The only way I can make plus 5 equals 0 is by doing the opposite. It's called the inverse operation. I'm going to subtract 5 to make 0. But again, if I subtract 5 from one side of my equal sign, I have to do it from the other side as well to keep it balanced. So x now equals 7 minus 5 is 2. And there's our answer. Our objective is to find the value of x. Now in lesson 2.R.7, it brings up some vocabulary. Okay, one of the vocabulary words that I'm going to introduce them as I go incrementally. One of the vocabulary words is the word conditional. Conditional simply means that we only have one answer, and our answer in this case is 2. X equals 2. So keep that in mind. When you only have one answer, your answer is conditional. Let's move on to another example. All right, let's get a little bit more interesting with this, right? The inverse operation of addition is subtraction. Well, what do you think the inverse operation of multiplication is? Division, right? 3 times z, so we'll divide by the 3 so that we can get the z alone on the left side of the equal sign. Z is now equal to a negative divided by a positive is a negative 7 in this case. Again, we have one answer, so what word will we use? Conditional. Again, this isn't, the word conditional won't pop up in all 3 of these lessons. It'll really, I think it only pops up in this lesson, where you'll get a question and it'll ask you what kind of answer will you have. In order to get there, you still have to work it out, even though it won't ask you for the numerical answer. It'll just ask you, is it conditional or, and I have 2 other vocabulary words, but don't stress over those yet. We'll talk about those in just a minute. That marker's starting to run out, so we'll get a fresh marker. All right, so what about, let's get a little bit more complicated with this thing. How about this? Negative 4v plus 20 equals 0. Let's solve this one. This one's going to have more than one step. See right here, we only had one step, divide. Here, we only had one step also to subtract. Here, we have to decide what to do. So let me just tell it to you like this. The negative 4 is attached to v. It's multiplied, but it's attached to v, whereas 20 is detached from V because there's a plus sign between them. The thing that is attached is the last thing you move. So we will move -4 last. Therefore, we'll move 20 first. The opposite of addition is subtraction, so we will subtract 20. So -4V is equal to 0 minus 20 is -20. Now we can divide by our -4, and when we do, we get V equals a negative divided by a negative is a positive. 20 divided by 4 is just plain 5. Again, we have a conditional solution. Conditional. Okay, so let's continue. Let me get a little eraser action going on. I think I say let's continue far too many times. All right, moving right along. Make it one up. All right, so how about 2x plus 3 equals 2, parenthesis, x plus 4. So let's go ahead and solve this example. First, I'm going to distribute. So I've got 2x plus 3 equals 2 times x, which is 2x, plus 2 times 4 is 8. Notice we have x on either side of our equal sign this time. We have to get them on the same side of the equal sign. You pick left or right. I'm going to send my x's to the left side of the equal sign, just how I prefer to see it. So I'm going to subtract this 2x because it's being added to the 8. Notice I'm not dividing by the 2 because we're not getting the x without the 2. We're not removing the 2 from the x yet. We're getting the x's together before we do that. We also have to, if we're going to subtract it here, we also have to subtract it here. Now we cannot, okay, I almost forgot to say this. The 2x is being subtracted from the 2x. We can't subtract it from the 8 because 8 doesn't have an x. Therefore, they would be unlike terms. Going back to simplifying algebraic expressions, which was a previous lesson, we don't subtract something that is an unlike term or add. Uh-oh. 2x minus 2x goes away. So now we have 3 equals 8. That's a lie, right? That ain't true. Whenever your answer is a false statement, 3 does not equal 8. That is false. Well, our vocabulary here, instead of conditional, our vocabulary here is the word contradiction. Right? Contradiction. All right. So again, whenever it works out to be a false statement, notice the variable is gone. We just have two numbers that are not actually equal to each other. The answer is contradiction. Another way to say that, because again, these things mean the same, right? So I'm feeding you vocabulary that means the exact same thing. Another word for contradiction, the answer to a problem that is a contradiction, a false statement, the answer, which I'm gonna put in this box, is the words no solution. Solution, remember, is the answer to a math question. And no solution has a symbol. It's a circle with a slash through it. So again, no solution. Or, depending upon how the question asks, it may ask you, is it a contradiction? So you just answer accordingly. I'll show you an example like that in a little while. All right, so let's take this thing to another level. (1.5x plus 2.1 equals 1.8x). Again, we have an x, which is a variable, on either side of our equal sign. So let's get them together. I'm going to suggest that we go right this time because 2.1 is already on the left side of the equal sign. And I don't want to have to move more than once. So let me make my move. Now, why am I subtracting 1.5? Well, it's being added to 2.1 and it's already positive. The opposite of a positive is a negative. 1.5 minus itself is 0x. So positive 2.1 equals 0.3x. 1.5 minus 1, I'm sorry, 1.8 minus 1.5. Now we divide by 0.3. The question I always get is, do we have to write the 0 in front of the 0.3? No, you don't have to. So x is equal to, when you type that in your calculator, you get 7. Is this conditional or is it contradiction? It's conditional because we actually have an answer for x. Negative z plus 11 equals 4z minus 4. Okay, so let's do this one. Again, let's go ahead and get our variables together on one side of the equal sign. It does not matter which direction you go. Again, I prefer to go left, so let's do that. I'm going to subtract 4z because 4z minus 4z will make 0 here. Negative 1z, that's a 1, right? Like a 1z, like baby swear. Okay. Negative 1z minus 4z is negative 5z. Plus 11 equals, and the negative 4 is now what's left on the right-hand side. Let's move the 11, because remember the negative 5 will be the last thing that we move. Subtract 11 from both sides. Negative 5z equals negative 4 minus 11 more. We're getting more negative, so negative 15. Let's finish it off with division. Divide by negative 5 on both sides, and we get z is equal to a negative divided by a negative is a positive 3. Conditional, right? There it is. So let's work this one out. All right, got a lot going on in this one. Before we can do anything, let's distribute. So we have 2x plus 5 equals 2x plus 10 minus 5. You see this right here? I see like terms on the same side of an equal sign, so we need to combine them like they are. So 2x plus 5 equals 2x plus 5. Whoa. Isn't it the exact same thing on either side of the equal sign? What that means is it doesn't matter what we plug in for x, we'll always get a true statement. Let me explain. If we put 0 in the place of x, right? Because in every other example we're getting an answer that we can plug back in, and it'll tell us what our statement would be. 2 times 0 is 0, plus 5 is 5. Same thing happens here, we're going to get 5 no matter what. If we put 1 in here, 2 times 1 is 2, plus 5 is 7. Same thing here, 7 equals 7. If we put 2 in here, 2 times 2 is 4, plus 5 is 9, and 9 definitely equals, 2 times 2 is 4, plus 5 is 9. 9 equals 9. In other words, every number that we pick to plug in for x in this problem, or substitute is the correct word, not plug in, I apologize. Whenever we substitute any number in, they will always give us a true statement. It might not be the same, but it'll be a true statement. In that case, we have what we call all real numbers or infinite, what did it say? Infinite solutions? Infinite solutions. And it is what it means, what it says, right? Infinite means every solution that we put in the place of x will be a correct answer. There's a symbol for that. Infinite solutions has, it's like a double R, right? Like two vertical bars on the double R. It means all real numbers can be substituted in. All right, so we had the conditional examples like these. We saw a contradiction example where we had no solution. Whenever we have infinite solutions, the word attached to infinite solutions is the word identity. Am I right? Yeah, okay. So we have an identity this time. All right, give me just a second. Okay, so here we go. I'm going to share my screen with you if I could find the right one. There it is. And okay, so look at this example, please. While I erase and copy it down, I want you to look at the vocabulary. This is from lesson 2.7, I'm sorry, 2.R.7. The vocabulary, it says, determine if the following equation is a conditional equation, an identity, or a contradiction. So on this question, all we have to do is identify conditional, identity, or contradiction. But in order to do that, we're going to have to work it out. So I've got 6x minus 3 in parentheses equals 7, and then 7 minus 4x, and finally plus 34x. All right, let's work this one out. All right, again, I see parentheses. I have an opportunity to distribute twice here. 6 times x and 6 times negative 3. 6 times x is 6x. 6 times negative 3 is negative 18. 7 times 7 is 49. 7 times negative 4 is negative or minus 28. X plus 34, x. See what I see here? Like terms on the same side, right side, of the equal sign. We can combine these two to make positive 6x. So what's going to happen now? Well, subtract 6x to get my x's together. Uh-oh. All of our x's are gone. And we got a false statement. What happens when we have a false statement? Our answer has no solution, and we call that a contradiction. All right, so pause it if you need to keep it. I'm gonna switch back over so you can see the screen. Share screen, here it comes. Contradiction is our answer. And I'm gonna go ahead and submit so you can see that we were correct. All right, so we can get a couple more examples in, especially one with a fraction, because maybe more than one with a fraction. I know very few people, if anyone, like fractions. I'm one of those people who don't like fractions. So 1/2 y plus 3 equals negative 1/9 y minus 4. Let's solve this one. Okay, so there's a strategy that I'd like for you to learn. Look at the two fractions, and their common denominator would be 18. We're going to multiply both sides of the equation by negative 18. So I'm going to multiply this thing by 18. I don't know why I said negative. And I'm going to multiply this thing by 18 as well. Okay, I just had to write it there because I kind of ran out of space, so I kind of wrote it up. Half of 18 is 9, or we could just reduce. 18 and the 2 reduce to 9. So we've got 9 times 1 times y plus 3. I know that looks like a lot of parentheses, and I'm going to simplify it in just a second. Equals, reduce here, 2 times negative 1 times y minus 4. We can simplify these two really simple. Really simple, just multiply those. 9 times y plus 3. Negative 2 times y minus 4. Nine y plus 27, notice we're just distributing. Negative 2y, and negative times negative is positive 8. All right, I've kind of run out of space here, so I'm going to move up over here. I'm just going to take this whole thing and bring it up here. All right, let's finish this thing off. Get my y's together on one side of the equal sign. I'm going to add 2y now because negative 2y plus 2y will cancel out. So 11y plus 27 is equal to 8. Subtract the 27. 11y equals negative 19. 8 minus 27 is negative 19. Remember, opposite signs. Subtract 27 minus 8 is 19. And then keep the sign of the 27. And we divide by 11. So our answer, y equals negative 19 11. In case you were wondering, I was checking to make sure I was right. You didn't do any more? That one? All right. So I'm going to do one more with a fraction. If you think of any others, let me know. All right, so here we go. 1/3 times y minus 1/3 equals 2/7 times y minus 1/7. All right, yuck. That's how I see it. I see 3's as denominators and 7's. So 3 times 7 is 21. That's our common denominator. Just like last time, I'm going to multiply each thing. Okay, so last time it looked a little bit different because we had a fraction. I don't remember what it was, but something like this, right? We had a fraction times to distribute, right? So we multiplied the whole thing by our common denominator, whatever it was. This time, we didn't have that situation. See, we don't have anything being distributed. So each thing individually has to be multiplied by that 21. 21 and 3 reduce to make 7. So we've got 7 times 1y minus. 21 and 3 again makes 7. So we have 7 times 1 equals. 21 and 7 reduce again to make 3. So 3 and 2y. And negative 1 times 3. 7 times 1 is 7y minus 7. 3 times 2 is 6y minus 1 times 3 is 3. All right. I'm getting tired. I know you are too. You probably already passed tired. I'm going to subtract 6y from both sides. It cancels here. 7y minus 6y is 1y. All right, these two just canceled off, and we subtract to make 1y. Add 7 to both sides. Y equals negative 3 plus 7 is 4. Again, this is a conditional answer. And I think I've covered everything. Good. All right. There it is. Let me get out the way so you can see. Oh, ta-da. Get my Vanna White on. I'm just kidding. Thank you very much. Stop recording. Goodbye.